Babies form memories. So why can't you remember yours? At 1-year-old, you may have remembered a face, a room, or the deeply personal betrayal of a spoon dropping from your high chair for the 6th time. Today, you remember none of it. Your first birthday could have featured cake, balloons, and one uncle filming vertically, yet your adult brain has archived the entire event under File Not Found. For years, one tempting explanation was that babies simply could not build the kind of memories adults make. Their hippocampus, a brain structure crucial for forming memories of individual experiences, was still developing. No proper save button, no file. Clean, sensible, possibly wrong. In 2025, researchers reported something remarkable in the journal Science. They collected usable brain scans from 26 awake infants aged roughly 4 months to 2 years. Half were younger than 1, and half were older. The words awake infants are doing heroic work here. Getting an adult to remain still in a brain scanner is already difficult. An adult understands instructions and can be bribed with the promise of leaving. A baby recognizes neither authority nor your research timeline. Inside the scanner, each infant saw a photograph of a face, object, or scene for 2 seconds. After several other images and a delay that averaged about 1 minute, the baby saw the old picture beside a new one. Because babies cannot announce, "Yes, I recognize the lamp from trial 7, the researchers tracked where they looked. Looking longer at the old image under these task conditions was treated as a sign of familiarity. Meanwhile, functional magnetic resonance imaging measured changes in blood oxygen associated with brain activity. The key question was not simply whether babies preferred old pictures overall. It was whether activity in the hippocampus when an image first appeared predicted how the same baby would look at it later. It did. Across trials, images that later received a familiarity response had been accompanied by greater hippocampal activity during their first appearance. The pattern was strongest in the back part of the hippocampus and clearer in infants older than about 12 months. In the younger group, from roughly 4 to 9 months, the researchers did not find the same subsequent memory effect. Around the first birthday, the infant hippocampus appeared capable of rapid, one-shot encoding of individual visual experiences. Translation: by about age 1, the brain is not merely absorbing general patterns like voices, rhythms, and the law that unattended biscuits become public property. It can create at least a rudimentary trace of a particular event. This challenges the broad idea that infantile amnesia exists because babies cannot encode individual experiences at all. Infantile amnesia is the strange gap at the beginning of your autobiography. Most adults recall little or nothing from their first 2 or 3 years, and early memories remain sparse for some time after that. Your life began, several seasons happened, and then consciousness apparently boots up halfway through a random afternoon near a sofa. If the hippocampus can save something around age 1, why can adult you not open it? One possibility is consolidation. A memory may begin forming but fail to stabilize for the long term. Another is storage. The trace may fade as the brain rapidly develops. Another is retrieval. The memory may persist in some form, but the adult brain no longer has the right route or cue to reach it. The filing system changes, the labels change, language arrives, your sense of self develops, and the password may have been something unhelpful like blue cup. Animal research makes the retrieval idea especially intriguing. In young rodents, early memory traces can sometimes persist but become inaccessible later, then reappear with strong reminders or direct activation of the relevant cells. That suggests forgetting does not always mean the original trace was completely erased. It can mean the trace is unavailable to ordinary recall. But this is where the viral version needs its tiny, responsible science seatbelt. The infant study did not show that your first birthday memory is intact somewhere, waiting for the correct smell of icing to unlock a cinematic flashback. It tested recognition after delays of roughly 20 to 100 seconds. It did not follow those babies for 20 years. It did not demonstrate adult autobiographical recall. The researchers themselves said richer memory features, including context, relationships, and free recall, still need to be studied. The babies also showed no overall familiarity preference as a group. The important result came from comparing trial-by-trial brain activity with later looking behavior inside each infant. Familiarity looking can be complicated. Babies sometimes look at the familiar image, sometimes at the novel one, depending on how well they learned it, how long they saw it, and whether the new picture has committed the crime of being more interesting. The study found evidence for a link under this task's conditions, not a universal decoder ring for baby thoughts. And even the encoding may have been incomplete. Each image appeared once, briefly. The resulting memory seems stronger over shorter delays. The authors describe the ability as emerging and possibly rudimentary. So the new picture is not encoding versus retrieval, winner takes all. Infantile amnesia may involve several stages: incomplete encoding, fragile consolidation, changing storage, and difficult retrieval, all collaborating on the most effective privacy setting ever applied to a human life. Language may be part of the story, but not because memories must be made of words. Babies clearly learn before they can speak. The problem is that adult autobiographical memory is organized through concepts, narratives, and a stable sense that the person in the memory is me. A 1-year-old's experience may be encoded in a format that later becomes hard to translate. Your brain did not merely add vocabulary. It rebuilt the interface while the old files were still inside. Rapid brain development may also change the hippocampal circuits that support access. New neurons and connections can be useful for learning, but remodeling a network may disturb old routes. Imagine renovating a library so enthusiastically that the books remain somewhere in the building, but aisle 7 is now a staircase, and the catalog thinks you are a different person. This does not mean recovered memory techniques can safely excavate exact events from infancy. Memory is reconstructive. Suggestion can create confidence without accuracy, and a vivid mental image is not proof that an early event happened. If somebody promises to unlock your baby memories with certainty, your hippocampus is not the only thing being manipulated. The beautiful part is simpler. The blank opening of your autobiography was not necessarily blank when you lived it. By around 1 year of age, at least some individual experiences appear to engage the hippocampus in a memory-like way. A baby may recognize, anticipate, and briefly remember far more than the adult version of that person can report. Those early experiences can matter through learning, attachment, and behavior, even when they never become stories you can consciously replay. Your first years may not be a missing chapter because nobody wrote anything. They may be notes written in a changing language, saved on a brain that was rebuilding itself at extraordinary speed. Some notes may fade, some may be overwritten, some may still influence the plot without ever becoming readable paragraphs. So no, the study did not demonstrate that your brain is deliberately hiding a perfect secret archive of baby footage. It showed something stranger. The machinery for encoding individual experiences appears to switch on during infancy, long before adult recall begins. The mystery has moved. We no longer only ask, can a baby save a memory? We ask, what happens to that memory after save? If you enjoyed this strange little journey, subscribe and help us reach 1 million curious minds. There are many more weird facts hiding in plain sight, and we intend to bother all of them. The only question left is, which one we bother next?